So in this video, we will solve Mathematics Paper 1, October-November 2016, and this is the second variant of Paper 1. So let's start with question number 1 here. So we have to evaluate this expression. So let's first solve this addition inside the brackets. So you have 4.273 and then plus 2.300. So we can add these zeros to make this addition easier. So 3 plus 0 is 3, 7 plus 0 is 7, 3 plus 2 is 5, 4 plus 2 is 6, and the decimal comes here. So you get 9.03 minus 6.573. So let's calculate that. 9.03 minus 6.573. So I'll add a 0 here. So I'll have to carry from this side. So this becomes 2, this becomes 10. 10 minus 3 is 7. So you cannot subtract 7 from 2. I cannot carry from here, so I'll have to carry from here. So this becomes 8. This becomes 10, but I'll have to carry one more. So this becomes 9, and this becomes not 2, but 12. So I brought here, this became 10, then I carry one more to this right side. So this became 9, and this 2 became 12. So 12 minus 7 is 5, and then 9 minus 5 is 4. Then the decimal 8 minus 6 is 2. So you get 2.457. So this will be your answer, 2.457. Next part is 8 by 9 minus 6 by 7. So you take the LCM of 9 and 7 would be 63. And then you multiply, since you multiplied 9 by 7, you multiply 8 by 7 as well. So 8 times 7 is 56, minus 6 times 9 is 54. So you get 2 over 63. 2 by 63. So given that this, and write down the values of 0.192 multiplied by 643. So here you can see that you know that 192 multiplied by 64.3 is this. So if we somehow manage to write this in terms of this, we can calculate this value. So to write 0.192 as 192, I'll have to write 192 over 100, right? Because 192 over 100, oh sorry, 1000. Because 192 over 1000 would be, you move the decimal 3 times to the right, 1, 2, and 3, so it becomes here. So that is actually 0.192. And then you multiply it by 64.3. So you have to write 643 as 64.3. So 64.3. And then since you moved the decimal to the right left here, then you have to multiply it by 10, because 64.3 multiplied by 10 will be 643. So this becomes equals to 192 multiplied by 64.3, and then this 0 and this 0 cancel out, and you get 100 in the denominator. So now this expression is exactly the same as this, so you can substitute the value here. You know that 192 times 64.3 is given by this 1, 2, 3, 4, 5.6 over 100. So it's divided by 100, so you move the decimal 2 places to the left. So you get 123.456. So 123.456. Part B is you have to calculate 12.3456 divided by 192. So if I take 192 to the other side of the equation in the denominator here, the two expressions will kind of look similar. So let me circle this, and so I take 192 to the other side, it becomes 64.3 equals to 12,345.6 divided by 192. So now if I can make this expression look similar to this, then I can substitute the value of 64.3. So let's write this down here. So this is 12.3456 divided by 192. So in both cases, I have 192 in the denominator, but for the numerator, I have 12,345.6 here, but 12.3456 here. So that means I need to move this decimal 1, 2, 3 places to the right to make it equivalent to this. So this is equals to, so if I move the decimal 3 places to the right, I get 12,345.6 divided by 192. But since I moved the decimal 3 places to the right, I have to divide it by 1000. So this is 1 over 1000 here. So now I can substitute the value of this. We know that this is equals to 64.3. So this becomes equals to 64.3 into 1 over 1000. So since it's 64.3 is being divided by 1000, I will move the decimal 3 places to the left, 1, 2, and 3. So we will add another 0 here. So this is equal to 0.0643. So this will be your final answer, 0.0643. So in the diagram, 5 small squares are shaded. Shade one more small square so that the diagram has exactly one line of symmetry. So line of symmetry, you know that it splits the diagram into two images, and these two images should be mirror image of one another. So let's start with like drawing an arbitrary line of symmetry. So this could be your line of symmetry, right? You split this big square exactly down the middle in half. So you have 2.5 width on the left and 2.5 on the right. But for this to be a line of symmetry, I have to have a mirror image. So if I have one shaded box here, then I need another one here. So this needs to be shaded. But you see also here, this is shaded, so I need to shade this one as well. So that means I'll have to shade two boxes. But the question states I have to shade just one box. So what other way can we split the big square into two small images that are mirror of one another? So this could be another line of symmetry. But then again, you have to, if this box is shaded, you have to shade this one. If this is shaded, you have to shade this one. If this is shaded, you have to shade this one. So these are, you have to shade more than one smaller box. So if we look at this line of symmetry here, now if you look at this line of symmetry and these two images above and below line of symmetry. So this box is shaded, that means this box has to be shaded, which is already. This box is shaded, that means you have to shade this box. And then if this box is shaded, we already have this box shaded. So we only have to shade this one box here to have this line of symmetry. And this will be the only line of symmetry, because if you look at the two images, they are mirror of one another. And if you like fold this big square across this line of symmetry, these will completely overlap. The two halves will completely overlap one another, and there is no other line that you can draw with which you can split it such that the two halves are mirror image of one another. So this would be your line of symmetry, and this is the box that you need to shade so that this actually becomes the line of symmetry for this diagram. So part B is in the diagram, 3 small squares are shaded. Shade one more small square so that the diagram has rotational symmetry of order 4. So first we need to calculate the degrees after which this pattern will repeat. That means you divide the full 360 degrees, which is one full rotation, divided by the symmetry order, which is 4 here. So 360 divided by 4 is 90 degrees. So that means this pattern of these shaded boxes will repeat every 90 degrees. So let me bring up this diagram here as well. So this is the same shape as in the question. So now I will rotate it 90 degrees. You can rotate your question paper to simulate this rotation that I am doing here. So once you have rotated it 90 degrees, you will compare it with the original diagram. So in this diagram, the boxes that are shaded should also be shaded in the original diagram, because the pattern is repeating after 90 degrees, and this is the same shape after a 90-degree rotation. So you're going to check these three. These three should be shaded in this original diagram. You can ignore this one because this is not shaded here. So you're basically looking for and making sure that all the shaded boxes after the rotation are also shaded in the original orientation. So this is shaded here. We have this box shaded, so that is fine. This box is shaded, and this is also shaded in the original one. We have this one shaded, but this one here is not shaded. So this is the box that we need to shade, this one. And once you have shaded the box, you can confirm whether this diagram, after you have shaded the box, has this rotational symmetry order 4. So let me bring this back to its original position at 0 degrees without any rotation. And then I will shade the box. So we shaded this one. So let me shade this here as well. So now this should have rotational symmetry order 4. That means this pattern will repeat after every 90 degrees. So if I rotate 90 degrees, now I have the same pattern as in the original diagram. And then if I rotate it another 90 degrees at 180, the pattern will repeat once more. So 180 is almost this direction. So you have these four shaded, these four shaded. And then at 270, which is another 90-degree rotation, the pattern repeats again. And then you're back to your original position at 360 degrees or 0 degrees. So during a full 360-degree rotation, the shape repeated itself 4 times. So that's why it has rotational symmetry of order 4. So that's how you will solve this question. So let's move on to the next question, question number 4 here. So the total cost of 3 pencils is $1.23. Find the total cost of 5 pencils. So cost of one pencil, this is one pencil would be equal to 1.23. So 1.23 divided by 3, and then cost of 5 pencils would be 1.23 divided by 3 into 5. And then I can simplify it to 123. I can remove this decimal and then divide by 100 just to make the calculation easier, since you do not have a calculator in this paper. So this 3 plus 2, 5 plus 1, 6. So this is actually divisible by 3. So 3 times 4 and then 1. And then 41 times 5 is 5, and 5 fours are 20. And then I have to divide by 100. So move the decimal 2 times left. So I get $2.05. So cost of 5 pencils would be $2.05. Arrange the following in order starting with the smallest. So I can convert all of them into decimals so that the comparison becomes easier. So 0.74% can be written as 74 over 100, which is 0.74. This is same, this is 0.77, and so on. So this is only negative 0.70. And negative 3 by 4, it can be written as, if you divide 3 by 4, you get 0 0.0. And then you can, 7 fours are 28, you get 2. You can add another 0 here, 20. And this is 5 times 20 and 0. So this is actually 0.75. So now let's start looking at these numbers and see which one is actually the smallest one here. So you have two negative numbers. One is negative 0.70, but the other one is negative 0.75. So negative 0.75 is the smallest. So that is negative 3 by 4, and then negative 0.7. And then out of these two positive numbers, one is 0.74, the other one is 0.777. So 0.74 is definitely smaller. So the next number would be 74%, and the last one is 0.777. So this is how you'll solve this problem. Let's move on to question number 5. In the diagram, ABC is a straight line. So this is a straight line. BF is parallel to DE. FBA is given as 74 degrees. DBF is given as 65 degrees. Find the angle CBD. So you have to find this angle here. So given this is a straight line, so CBD plus 74 plus 65 should equal 180. So CBD should equal 180 minus 5 plus 4 is 9, and 7 plus 6 is 13, 139. So if you subtract 139 from 180, you get 41 degrees. So CBD is 41 degrees. Find the reflex angle BDE. So the reflex angle is this one, angle which is greater than 180 but less than 360. So this is your reflex angle BDE that you have to find. So since these two lines are parallel, we can actually find this angle, the internal BDE angle. We know these two are parallel lines, and the sum of the internal angles of parallel lines is 180. So your angle, let me call it BDE plus 65 is equals to 180. And this gives you BDE to be equals to 115 degrees. Now for reflex angle BDE would be equal to 360 minus this. So that will be 360 minus 115, which is equals to 360 minus 100 would be 260, 250, and then 245 degrees. So your reflex angle BDE, this one here, is 245 degrees. Question number 6 is, by making suitable approximation, estimate the value of this. Show clearly the approximations you use. So we can approximate 3.98 to be 4. So let's approximate everything to one significant figure. So 602.3 can be written as 600 to one significant figure, and then 2.987 can be written as 3. Square root of 4 is 2 times 600 divided by 3. So 3 times 1, 3 times 2, 200. So you get 400. So your answer is 400. You can also solve this by approximating 602.3 to 602. That will make this calculation a little bit complicated, but that is also an acceptable answer. So question number 7 is, the diagram shows this triangle A. A is mapped onto triangle B by an enlargement. The enlargement has center 3, 3 and scale factor -2. So you have to draw the triangle B. So your center of enlargement is this point 3, 3. Let's call this O. And let's mark the vertices of this triangle A as P, Q, and R. So to enlarge this triangle A with a factor of -2, one method to do this would be, you measure this length from P to O. It's almost 2.5 centimeter. So if this is 2.5 centimeter, then the length, let me just write here. So let's say P will be mapped onto P1, Q would be mapped onto Q1, and R would be mapped onto R1. So this is triangle A and this is triangle B. So if this length OP is 2.5 centimeter, then the length OP1 should be twice, because the scale factor is 2, so it should be 5 centimeter. And since there's a negative sign, it should be on the opposite side of the center of enlargement. So if this is 2.5, then my OP1 should be 5 centimeter up till here. So I get this point here. This point right here would be at 7 and 5 would be my point P1. And then you can do similarly for Q. You connect Q with O and then you double the length on the other side. But sometimes it gets difficult because you won't always get these nice numbers like 2.5. You can easily double it to 5. Sometimes you will have to deal with decimal numbers, and you might find it difficult to find what's the double length and what's the direction. Is it on the same side or is it on the other side? So I'll show you a method which I feel is easier uh, to do these sorts of enlargement. So let's again mark your center of enlargement here, which is 3, 3, right? So let's assume that this is your origin and then find what's the coordinate of P. So if this is your origin, if you're starting from this point, you're moving 2 points to the left in negative x. So we write the coordinates in a column vector. So if you're moving 2 points to the negative x-axis, you will have -2 here, and then you're moving 1 point in the negative y direction, so you will get -1 here. So this is simply writing the xy coordinates in the column vector. So -2, -1. So since your P is -2, -1, then your P1 would be -2, -1, and simply multiplied by the scale factor, which is -2. So P1 would be -2 times -2 is 4, and then -1 times -2 is 2. So your coordinates of P1 are 4, 2. But remember, these four, the x direction 4 and the y direction 2 is from this center. You're not moving from origin. You're moving from this center. This is your center of enlargement. So you move 4 points to the right, 1, 2, 3, 4, and then 2 points in the positive y direction, 1, and then 2. So you get P1 here. And we can do the similar calculation for, let me just move it out of the way. So similar calculation for Q and R as well. So your Q is, you move in x direction, +1 from the center of enlargement. So your Q is 1, and then -1 in the y direction, so -1. So your Q1, which is part of triangle B, would be 1, -1, and then multiplied by the scaling factor, which is -2. So you get -2 and then +2. So -2 means you move 2 points to the left on the x-axis from your center of enlargement, and then 2 points in the positive y direction. So you end up here, which is Q1. And then for R, you can get R is 1 in positive x and +1 in y. So you get 1, 1 here. And then to get R1, you get 1, 1 multiplied by -2. So you get -2 and then -2. So from the center of enlargement, you go -2 in x and -2 in y. So you end up here, which is R1. So this would be your triangle B right here. You connect all the three vertices. And this will be your, so I feel this method is much more easier. You can calculate each corresponding points by simply multiplying their relative position from the center of enlargement by the scaling factor. So you get P1, Q1, R1, and then you can join them. So this would be your triangle P. Question number 8 is write this number in standard form. So for standard form, you'll have to move your decimal here after 5. So 1, 2, 3, 4, 5 places to the left. So this becomes 5.13 into 10 power 5, since you moved your decimal 5 places to the left. So 5.13 into 10 power 5. Expressing your answer in standard form, evaluate this. So you have 4 into 10 power minus 5 multiplied by 6 into 10 power minus 4. So 6 times 4 is 24, and then since you're multiplying, you'll add these powers of 10. So you'll get -9. So to get standard form, you'll have to move the decimal one place to the left. So you get 2.4. And since you moved decimal one place to the left, you will increase the power of 10 by 1. So you will get -8. So you'll have 2.4 into 10 power minus 8. Question 9 is, the diagram shows part of the histogram which represents the distribution of times taken by some people to travel to work. So we have to complete the table. So we are given the time intervals 0 to 20, 20 to 20, 20 to 30, and so on. So you have to fill the table. So the missing frequencies here is, for the first one is for 0 to 20. So your frequency will be area under this bar. So you have one length is 20 and the height is 1. So 20 times 1 is 20. So this frequency will be 20. Then the next missing value is for the interval from 30 to 35. Here the height is 5 and width is 5 as well. So 5 times 5 is 25. And then we have to complete the histogram. So the bar remaining is the missing bar is for the interval 35 to 50. So frequency density that you need to find would be 30, which is the frequency, divided by the interval width, which is 50 minus 35, 15. So you get 2. So the height of your histogram for this interval will be 2. So this is how you will draw this. Question 10. So you have given f of x 4 plus 3x. You have to find f of negative 2.5. So you just replace x with negative 2.5. So 4 plus 3 times negative 2 times 4, 5 by 2. So this becomes 4 plus, sorry, this would become actually negative. So 4 minus 15 over 2. Then you take the LCM, it becomes 18. Oh, sorry, 8 here minus 15 by 2. And this is equals to negative 5 plus 3. Sorry, 5 plus 2, 7 by 2. Negative 7 by 2 or negative 3.5. So your answer is minus 3.5. Part B is find f inverse of 5. So first we need to find the inverse of this function. So we let y equals to f of x. This gives you f inverse of y equals to x. If I take this function on the other side, this becomes inverse and you're left with x on this side. So y equals to f of x. F of x is 4 plus 3x. 4 plus 3x. Then I make x the subject of this equation. 5 minus 4. And then x equals to y minus 4 over 3. So we know that f inverse of y is x, which is y minus 4 over 3. So f inverse of x would be x minus 4 over 3. Now you have to find f inverse of 5. So f inverse of 5 would be, you replace x with 5 here. So 5 minus 4 by 3, which is 1 over 3. So your answer is 1 over 3. Question 11 is y varies inversely as the square of x. So y is inversely proportional to the square of x. So y equals to a constant k over x squared. When x equals to 2, y equals to 9, find the value of y when x equals to 3. So first we need to find the value of the constant k. For x equals to 2, y is 9. So I replace these two values in this equation. So y is 9 equals to k over x is 2, so 2 squared. This gives me k equals to 9 times 4, which is 36. So now we need to find the value of y when x equals to 3. So y equals to k is 36 over x squared. And then if I replace x with 3, I get 3 squared, which is 36 over 9, which is 4. So y equals to 4 in that case. Part B is when x equals to n, y equals to p. Write down an expression for y in terms of p when x equals to 2n. So similar to how we did it in the previous part, first we need to find the value of the constant. So y equals to k over x squared. When x equals to n, y equals to p. So y is p and x is n, which becomes n squared. This gives you k equals to n squared p. So this is your constant. Now you have to find y when x is 2n. So y equals to k over x squared. Replace the values. K is n squared p, and then x is 2n, which is 2n squared. So this becomes n squared p over 4n squared. N squared cancel out. You get p by 4. So this is p over 4. Question 12 is a school recorded the number of absent students over a 50-day period. The results are given in the table below. So there were 25 days when no student was absent. So zero student were absent on 25 days. There were 15 days with one student absent, 6 days with two students absent, and so on. So write down the mod. So mod is the value with the highest frequency. So the highest frequency here is 25. So the mod value would be 0. Calculate the mean. So mean would be mean equals to total number of students absent divided by total number of days. So you can find the total number of students absent by using the table. So 25 times 0 plus 1 multiplied by 15. Let me write it properly. 1 multiplied by 15 plus 2 times 6 plus 3 times 3 plus 4 times 1, and then total number of days is 50, which is the sum of these values. So divided by 50. So once you add these, 25 times 0 is 0. You get 15 plus 12 plus 9 plus 4 divided by 50. And if you add these, 15 plus 12 is 27, 36, 38. 38 over 50. 27 plus 9 is 36. 36 plus 4 is 40. Sorry. So this is 14. So 40 over 50 cancels out. So this will be equal to 0.8. So you get 0.8, your final answer. Question 13 is triangle ABC is mapped onto triangle A prime, B prime, and C prime by a rotation with center O through 110 degrees clockwise. Draw and label triangle A prime, B prime, and C prime. So clockwise rotation of 110 degrees means clockwise would be in this direction, and you have to go 110 degrees. So we can use our geometric tools to solve this question. First, we will connect our points to the center of rotation so that we can compute the rotation and the distance of the new points, A prime, B prime, and C prime. So let's first connect this through this dotted line here. So this will connect both A and B to this center O, and then we can connect C as well to the center of rotation. So it will be this dotted line here. So let's start with point A. Let me put my protractor at the center here, right about here. So this is at 0 degrees. So my 90 degrees here, and then I have to go up till 110. So 90, 100, and 110 where this 70 is marked. So after 110 degree rotation, I will get a point somewhere here. But I also need to compute the distance of the point A prime, to which this A is mapped to. So I know that it's somewhere in this direction. This is 110 degrees, but I don't know if it's here or there. So to do that, to find the distance, I'll use my compass. So I will place it at center O, and then I will open it up till A. So right about here. So now I have this width, the distance here would be equal to the length OA, and then I can draw an arc here. Oops, oh, I changed this. Let me do it again. So I accidentally changed the width. So let me put it back here and open it up till A. Okay, let's do this again. So my arc would be this. So now I can, so this is my point A. Let me actually draw the line so that it's easier to visualize. So I have to draw, so your dot that you marked using your protractor gives you the angle, and the arc actually gives you the distance of A prime. So my A prime would be somewhere along this line until I reach the arc. Here we go. So this point here, this is your A prime. Let me actually mark it as well. So this is A prime here. So to compute B prime, I will draw another arc. This time I will center it here at O, and then I will open it up till point B, which is right about here. And then since A and B lie on the same line, straight line that connects them to O, so your angle is still represented with this dot, which is at 110 degrees. But now your arc will be closer to point O here, since B is closer to O when compared with A. So this is your arc. And this intersection here will give you the point B prime. So let me mark B prime here. So this would be your point B prime. And then to get C prime, I will again put my protractor at the center. And now you have to rotate it because your 0-degree angle is this, since this is the line connecting C and O. So now your 110 degrees will be, so 90 here, 100, and then 110 would be here. So this is your 110 degrees. And then I also have to uh, draw the arc which represents this distance OC. So let me open it up till C, which is here. And then I will rotate it here and draw the arc here. And then I need to use my ruler here to connect the arc with center O. So you have to place it this angle. So again, the dot represents the angle, and then you have to draw the line till the arc to get the correct distance. So I can draw here, here. So this is your point, C prime. Let me mark it here. So this is C prime. So now you have all the three vertices of the new triangle, A prime, B prime, and C prime. The last thing that we need to do is just to connect them with a straight line to basically get the triangle. So let me connect these two first. So this is your length A prime, B prime. And then I can join these B prime and C prime as well, like this. And then I can also join A prime and C prime like this. So this gives you the new triangle A prime, B prime, and C prime, which is rotated at 110 degrees. So all of these angles for AB, you computed this angle. This is 110 degrees, and for to rotate C, I rotated through this angle here, which is also 110 degrees. So this is your new triangle A prime, B prime, and C prime. Question 14 is in the Venn diagram, shade the region which represents the subset A intersection B complement, then union C. So we can first start off with finding the region that is represented inside the brackets here, and then we will do a union of that region with C. So B complement is everything outside B. So this is B here. So everything except inside this circle here is represented by B complement. So everything outside this circle is B complement, and you have to find the intersection of that with A. So everything outside this circle that intersects with A is this region here, right? So this is outside B, but also part of A, which gives you the intersection A intersection B complement. And then you have to find the union of this region. So this blue is this bracket here. So this region blue is represented by this A intersection B complement. And now you have to find the union with C. So that means this region here that you have computed already, and then everything in C. So this is part of C, which is already part of the region that you computed, so you won't count it again. So what is C? The rest of C is this. So you did a union of this region with whole of C. So you get wholes of C as well as this one, which you computed first, which is represented in the brackets here. So this is A intersection B complement is this, and then union with C gives you this as well. So this is your final shaded region that you will get in for this question. The next part is in a group of 36 students, 23 study Spanish, 17 study French, 4 study neither Spanish nor French. So we have to draw a Venn diagram and then find the number of students who study both Spanish and French. So let's draw the Venn diagram. It will make it easier to visualize what's happening here. So you have your universal set here. So you have 36 total students, and then let me draw this Spanish. Let me represent it by S in red, and then let's say French is green here. So you know that 4 students study neither Spanish nor French. So that means they're not part of any of these sets. So they will be outside here. So 4 students are here. And then 23 study Spanish. So 23 are in this set S. And 17 study French. So 17 are in this set F represented in green. But there is an overlap here that we need to compute as well. So let's say that the overlap here is X. So number of students that study both Spanish and French equals to X, represented by the intersection of these two sets here. So if X is the number of students that study both Spanish and French, how many study Spanish only? So we are given that 23 study Spanish. So this region here will be 23 minus X, because X is in this intersection. So your whole sum, the number of total students that study Spanish would be 23 minus x plus x, which will give you 23 as given in the question. And similarly, for French, we know x is an overlap. Total number of students that study French is 17. So students that study only French would be 17 minus x here, right? And then we can compute the value of x, as we know that the total number of students is 36. That means if you add up all these numbers, they should sum up to 36. So that is number of students who study Spanish only, number of students who study French only, plus the number of students who both study both Spanish and French, plus the number of students who study neither Spanish nor French. So that will be 23 minus x plus 17 minus x plus 4 should equal 36. And then we can solve this for x. So x plus x and minus it cancel out. 17 plus 23 would be 20, 30, 40. 40 plus 4 would be 44. So this will be minus x plus 44 equals to 36. And this will give you x equals to 8. So your answer is 8 here. So 8 students study both Spanish and French. Let's move on to the next question, question number 15. So you are given two simultaneous equations that you have to solve to get the values of x and y. So let me mark this as equation 1, this as 2. So from 1, I can find the value of y in terms of x. So y would be equals to 9 minus 3x. So I'm using the substitution method here. You can solve it with elimination as well. So I'll substitute y. So substitute y in 2. So you get 2x plus 3y. So y I know is now 9 minus 3x equals to minus 8. So this becomes equals to 2x plus 9 times 3 is 27 minus 9x equals to minus 8. Minus 9 plus 2 is minus 7x equals to minus 8 minus 27. I'll continue here at the top. Minus 7x will equal minus 27 minus 8 would be minus 35. 27 plus 8 is minus 35, and then x will equals to 5 here. And then put, let me call this 3. Put x in 3 here, so you get y equals to 9 minus 3 times x. X is 5. So you get 9 minus 15, which is equals to negative 6. So your x value is 5, and then your y value is negative 6. Question 16 is you have to evaluate this expression. So you know 3 squared is 9, 3 power 1 is 3, and 3 power 0 or anything power 0 is 1. So you get 1 here. So 9 plus 3 is 12, 12 plus 1, 13. So this is 13. And then you have to evaluate 4 by 3 whole to the power negative 2. So you bring the power in, you get 4 negative power 2, power negative 2, 3 power negative 2. And then you can take the reciprocal so that the powers become positive. So you bring this 3 up and bring this 4 down. So you get 3 squared over 4 squared, which is 9 over 16. 9 over 16. And then we have to simplify this. So you bring the power inside the bracket. So you get 16 power 1 by 2. And then y power 6 times 1 by 2. Since you bring the power in, you have to multiply the existing powers with 1 by 2. So 16 power 1 by 2, which is like square root. So 16 square root of 16 is 4. So you get 4 here. And then you can cancel out 2 and 3. So you get y cube. So 4y cube. Question 17 is some money is shared between Ali, Ben, and Carl in the ratio 5 ratio 3 ratio 2. Ben receives $60. How much money is shared? So what is the total money that you need to calculate? That's what you need to calculate. So total money, let's say, equals to X. So you know that Ben receives $60 and his share was 3 out of the total. So you can calculate the total proportion here, which is 5 plus 3 equals 8 plus 2, 10. So he received 3 by 10 of the total money, which is total money is X. And what was his share? His share was $60. So Ben received 3/10 of the total, which is X, and his share was $60. So then we can solve for X. You bring this 10 here, 3 down here, so you get 600 divided by 3 here, which is $200. So total money that was shared was 200. Express the ratio 3.5 hours ratio 14 minutes in the form K ratio 1. So we have to convert this into minutes as well, as we need K ratio 1, which means everything should be in minutes here. So 3.5 hours in minutes would be 3.5 hours equals to 3 into 60 plus 30. Half hour is 30 minutes. So you get 180 plus 30, which is 210. So here the ratio is 210 ratio 14, and we can cancel. If we divide 210 here by 14, I get 14 times 1 is 14, remainder is 770. If I bring this 0 down, I get 70, and 14 times 5 is 70, so you get 0. So this is 15 ratio 1. So you'll have 15 here and then ratio 1. Question 18 is 4 cards are marked with numbers 1, 2, 3, 4. One card is chosen at random, and then a second card is chosen at random from the remaining 3 cards. So you're choosing without replacement. You pick one and then you pick the other one without putting the first one back. So the sum of the numbers on the 2 chosen cards is calculated. Complete the table to show the possible outcome. So you have to complete this table, which represents the sum of the 2 cards. And you can see here these boxes are blanked out, because if you pick the first card as 1, you cannot pick the second card as 1, because it's already out of the uh, remaining cards that you have to choose from. So if you pick the first card as 2 and the second card as 1, then the sum is 2 plus 1, 3. If you pick the first card as 3 and the second card you picked was 1, then the sum is 4. So you fill out the table similarly here. 4 plus 1, 5. This is 3. Then this is 5 as well. This is 6. 3 plus 1 is 4. 3 plus 2 is 5. 4 plus 3 is 7. 4 plus 1 is 5. 4 plus 2 is 6. 4 plus 3, 7. So let me just make sure I got everything right here. Part B is, what is the probability that the sum is less than 2? So these are all the possible outcomes that you can get, right? If you pick one card and then you pick the second card without replacement, these are all the possible combinations. So what is the probability that the sum is less than 2? So you don't see any sum that is less than 2. So the probability of getting 2 cards with sum less than 2 is 0. So what is the probability that the sum is greater than 5? So greater than 5 means you either get this is 6, this is also greater than 5, 7 is also greater than 5, this 7 is greater than 5 as well. So there are 4 possible outcomes where the sum would be greater than 5. And what are the total number of possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total outcomes are 12, and out of the 12, there are 4 outcomes where the sum is greater than 5. So your uh, answer is 4 by 12. You can also simplify it to 2 by 6. In fact, 1 by 3. This is an equal sign here. Let's move on to the next question. Question 19 is, a box has a mass of 1.7 kg. Correct to the nearest 0.1 kg. Write down the lower bound for the mass of the box. So your degree of accuracy is 0.1. So your error is always degree of accuracy divided by 2, which gives you 0.05. So you have to find the lower bound. So lower bound would be equal to the mass minus the error. For the lower bound, you subtract the error. So 1.7 minus 0.05 will give you 1.65 kg. So your answer is 1.65. Part B is the box holds 100 jars. Each jar has a mass of 140 grams, correct to the nearest 10 grams. Calculate the lower bound of total mass of the box and 100 jars, giving your answer in kilograms. So you have to find the lower bound of total mass of box and 100 jars. So lower bound, so let's call it total lower bound is equals to get the total overall lower bound of the mass of box and 100 jars means I have to add the lower bound of, lower bound mass of the box plus lower bound mass of 100 jars, right? That will give me the total lower bound of the total mass of the box and 100 jars. So you have already calculated the lower bound mass of the box in the first part, which is 1.65 kg. All I need to do is to calculate the lower bound mass of 100 jars. So lower bound mass of the box is 1.65. So that will be 1.65 plus lower bound mass of 100 jars. So let's first calculate the lower bound mass of one jar. Let me write it here on the right. So first let's find the error. Error is the degree of accuracy, which is 10 grams divided by 2. So 10 divided by 2 is 5. So lower, this is separate here from this. So this is lower bound mass of one jar equals to 140 minus the error, which is 5. So this gives you 135 grams. And then lower bound mass of 100 jars would be equals to 135 multiplied by 100. So this gives you 13,500 grams. Since we are calculating in kg, I can convert this into kg. I'll get 13.5 kilogram. So my lower bound mass of 100 jars here that I need is 13.5. So if I add these together, so let me add 13.5 plus 1.65. So I'll add a 0 here. So 5, 6 plus 5 is 11, 1 carry, 3, 4, 5, and the decimal here 15.15. So your answer would be 15.15. 15.15 kg. So question 20 is you have to solve this equation and find the value of x. So since x is in both of these fractions, I can calculate the LCM, which will be 12. So since I multiplied the denominator 4 here with 3 to get 12, I'll have to multiply by 3 in the numerator as well. So I get 3 into 2x minus 1, and then plus I multiplied 3 with 4 to get the denominator to 12. So I have to multiply 4 in the numerator as well. So 4 into x minus 2 equals to 2. I open the bracket. This gives me 6x minus 3 plus 4x minus 8 over 12 equals to 2. I can take the 12 to the other side and also add and subtract these values on the top. So 6x plus 4x is 10x, minus 3 minus 8 is minus 11, and then 12 taken to the other side here, it will be equal to 24. And then 10x equals to 24 plus 11 would be 35, and then x would be 3.5. So your value of x is 3.5. So question number 21 here is the volume of a sphere is 4 by 3 pi r cube. So during a storm, raindrops fall into a cylinder which stands on horizontal ground. The cylinder was empty before the storm started. The cylinder has radius 20 millimeter. Each raindrop is a sphere of radius 2 millimeter. after the storm, the depth of the water in the cylinder is 16 millimeter. Calculate the number of raindrops that fell into the cylinder. So let's say we have a cylinder here, and we are given the cylinder has radius 20 millimeters. So this radius here is 20 millimeter, and you're not given the initial, like the height of the cylinder, right? The radius, sphere radius, and the depth of the water in cylinder 16. Okay, so you have raindrops that are coming into the cylinder, and each raindrop is a sphere of radius 2 millimeters. So let me like enlarge this to a sphere with radius 2 millimeters. So this is your like one raindrop enlarged. So all the raindrops that are coming in here, and after the storm, the depth of water in the cylinder here is 16 millimeters. So the water, let's say, is up till this level. So this is 16 millimeter. So calculate the number of raindrops that fell into the cylinder. So if the height of water here is 16 millimeter, the volume of water in the cylinder would be, we know that the formula for the volume of cylinder is pi r squared h. So you know R, you also know H, which is the height of water. So I can calculate the volume of water in the cylinder by the formula pi r square H, right? So that will give me the volume of this water inside the cylinder. But this volume came from all the raindrops that came in, right? And we can, since we know the volume of uh, water in the cylinder, I can actually find the number of raindrops by dividing the volume, total volume, by the volume of one raindrop to get the number of raindrops that we need. So let's say volume of water in cylinder equals to pi r squared h. R square would be 20 squared. I can leave it in terms of pi to make the calculation easier, and then this is 16. So this is pi into 400 into 16, which is basically 16 times 4 is 6 fours are 24, 2 carry, 4 ones are 464. So this will give me 6400 pi millimeter cube. So this is the volume of water in the cylinder here. So let's calculate volume of one drop. So you're given that it's a sphere, and the formula is here 4 by 3 pi r cube, 4 by 3 pi, and you're given the radius of the raindrop is 2 millimeters. So into 2 cube. So 2 twos are 4, 4 twos are 8, and 8 times 4 is 24. So you'll get 24. Oh, sorry. This would be 2 twos are 4, 4 twos are 8, and 8 times 4 is 32. 32 by 3 pi millimeter cube. So how many raindrops do we need to get to this volume? We divide the total volume by volume of one raindrop to get the number of raindrops. So number of raindrops would be equal to total volume, which is 6400 pi, and then divide by volume of one raindrop, which is 32 by 3 pi. So pi and pi cancel out, and then let me bring this up. 6400 into 3 by 32, and let me see if I can, yeah, I can simplify it by dividing it by 16. 16 times 2 is 32. 16 times 4 is 64, and then 2 zeros. And then I can further divide by 2. 2 ones are 2, 2 twos are 4, and 200. So 200 times 3 is 600. So one drop has volume this, and 600 drops will have the volume of 6400 pi, which is the volume of water that we gathered in the cylinder because of the rain. So that is equals to 600. So question number 22 is about loci. The diagram shows the triangle ABC. Part A is construct the locus of points inside the triangle ABC that are equidistant from A and B. So that means we have to draw the perpendicular bisector of line AB. For that, we will need our compass. So to draw the perpendicular bisector, we center the compass around the first point A, and then you have to open the compass more than halfway. So if this is like the midpoint, I can open it up till here. So it's the width of the compass is more than the halfway of line AB. So then I can draw two arcs here, one on this side and the other on this side. And then without changing the width of the compass, I'll place it on the other point at B, and then I'll draw another arc here and then another arc on the other side here. So if I connect these 2 points, I will get the perpendicular bisector of line AB. So I'll use my ruler for that. And so this will connect these 2 points. But remember, the question asks to draw the locus just inside this triangle ABC. So I'll start off with this boundary of triangle AB, the line AB, which is the boundary of triangle on this side, and draw up till this boundary. So I don't have to draw this part which is outside the triangle. So this is part A, which is the locus inside triangle ABC that are equidistant from A and B, points A and B. Part B is construct the locus of points inside the triangle ABC that are equidistant from AB and BC. So that means we have to draw the angle bisector of angle ABC. So the angle bisector will be somewhere down the middle here. So all the points on that line would be equidistant from line BC and line AB. So to draw the angle bisector, I'll place my compass on point B here, and then I'll just open it up to a reasonable amount so I can draw the first arc here. So I'll start at this point and draw this arc here. And then I'll place the compass on this point where the arc intersects one of the lines, which is BC, line BC, and draw another arc here. And then place the compass without changing the width of the compass on the other intersection point of the arc with line AB in this case. And then I will draw the other arc here. So now if I connect this point B with this point, I will get the angle bisector of angle ABC. So let me position this here and then here. So now I can draw the angle bisector, and again you have to remain inside the triangle ABC. So I'll start here at this point, and then you draw up till this boundary. So this is your part B. So all the points on this line here on the angle bisector will have equal distance from line BC and line AB. Part C is on the diagram, shade the region inside the triangle ABC which contains the points that are nearer to A than to B. So nearer to A than to B means, so this is your line bisector of line AB. So anything below this line bisector, this one here, anything below this line, which is all this region here, is closer to A. So you're looking for some region here below this line. The other condition is the points in the region are nearer to BC than AB. So all the points towards the right of this angle bisector are closer to line BC compared to line AB. So you're looking for a region that is towards the right of this angle bisector and below this perpendicular bisector of AB. So that region will be this one here. So it's below the perpendicular bisector and towards the right of the angle bisector. So all the points in the region are closer to A compared to B and closer to line BC compared to line AB. So this whole region here would be shaded. Question 23 is the diagram shows a square piece of card from which a triangle, this one here, and two small squares, this and this, are removed. All lengths on the diagram are in centimeters. Calculate the area of the shaded card. So you have to find the area of the shaded region which remains after you have removed this triangle, this square, and this square from the original big square. So what we can do is find the area of this big square and then subtract the area of this smaller square and this smaller square and this triangle, and we will get the area of the shaded region. So we can mark the lengths that we know. So if this is 1 and we know this is a square as stated in the question, so this length here, this here will be 1 as well. Since this is 1 and this whole length is 5, that means this length here would be 4. And since this is 2 and this is a square, so this length here and this length here will be 2 as well. Both are the same. And to get this length, so we know this whole length is 5 and this length is 2, 2. And so since this whole length is 5, then this will be 5 minus 2, which is 3. So now I can compute the area of the shaded region. So area of shaded card will be equal to the area of this big square, which is 5 into 5, and then minus the area of this small square, which is 1 into 1, area of this small square, which is, so you subtract this as well, so 2 into 2, and minus the area of this triangle here, which is minus 1 by 2 into base is 3 and height is 4. So 3 times 4. So this is big square. This is small square. This is also the small square. Let's call it small square 2. And this is the triangle. So 5 times 5 is 25, minus 1 minus 4, and this will be 2 times 1 and 2 times 2, so 3 times 2 is 6. So 25 minus 11, which will give you 14. So the area of the shaded region is 14 centimeters square. The next part is calculate the perimeter of the shaded card. So let's say perimeter. So now you have to find the perimeter. So let me mark the perimeter in red. So this here, this length, then this length here, this length here, this, then this hypotenuse here, and this length, and then this length. So this is your perimeter of the shaded region. So let's start with the top length here. So we know that this is 1, so this red length here would be 4. We know this whole is 5, but this is 2, so this is 5 minus 2, 3. Let me in fact write it in red so we don't confuse it. So this is 4, this is 3, this is 2, we know, this is 2 as well. This is the hypotenuse of this right angled triangle. Since this is a square, this is 90 degree here. So you can calculate this using the Pythagoras theorem. And then this length here is 1 as well. And this length here is 1 as well. So Let me say the hypotenuse square is equals to 3 square plus 4 square. So hypotenuse square is 9 plus 16, 25, and then if you take the square root of 25, you get 5. So this length here is 5. So let's all add these up. So let's start from the top, where I'll go in like clockwise direction, 4, 3, 2, and add them all up. So 4 plus 3 plus 2 plus 2 plus 5 plus 1 plus 1. So 4 plus 3, 7, 9, 11, 16, 17, 18. So your perimeter is 18 centimeter. Let's go to the next question. So in the diagram, A, B, C, D, E lie on the circle. So these are the points on the circumference of the circle, and the center of the circle is O. BOE is a straight line. So since it's a straight line and it passes through the center, this means that BOE is also the diameter of this circle. Angle DAB here is 34 degrees. So the first part is find X. So to find X, if we look at this angle, so X is this angle DOB. And so if we look at this angle here, so this is angle X that we need to calculate, and it's at the center, right? But if we look at the same, so this is the arc. This arc is, this angle X is subtended by this arc DCB. But if you look, this arc DCB also makes this angle DAB here. So this angle DAB is also subtended by the same arc but is on the circumference. So we can use the property that angles subtended by the same arc, if one is at the circumference and one is at the center, the one at the center is twice of the angle at the circumference. So your X will be 34 into 2, which is 68 degrees. So X is 68. The next part is find Y. So let me erase the previous here lines that I made so that it's cleaner to understand. So now we have to find the value of Y. So if you look at this quadrilateral DCB AD. So this quadrilateral DCBA, it is actually a cyclic quadrilateral because all four corners are on the circumference of the circle. And we know the property of cyclic quadrilaterals that opposite angles sum up to 180 degrees. So y plus 34 should be equal to 180. So that gives you y equals to 146 degrees. So y is 146 degrees. The next part is find z. So let me again erase this. So let's see. Z is angle DE and then B, and it's subtended by this arc DCB here, right? So this arc DCB subtends this angle E at the circumference. But if you look again, this arc also subtends this angle DAB. So both these are angles DAB and DEB are subtended by the same arc and both are at the circumference. So we know that angles subtended by the same arc on the circumference of the circle are equal. So your Z will be also equals to 34 degrees. So Z would be 34. The last part is find T. So let me again erase this. So for T, if you look at this triangle, which is B, E, and then A. So this, let me make it a little better. Right. So if you look at this triangle, BEA, this angle is in a semicircle and it's subtended from this diameter. So we know any angle subtended in a semicircle from the diameter of a circle is 90 degrees. So this angle, this full angle is actually 90 degrees. So T plus 34 will be equal to 90. So T would be 90 minus 34, which is 56. So T would be equal to 56 degrees. So let's move on to the next question. So in the diagram, the line 3y plus 2x equals to 13. So this is the line equation of the line meets the axis at A. So it meets y-axis at A and x-axis at B. Find the coordinates of A. So to find the coordinates of A, you will substitute the x value, which is 0 here in this equation to get the y value. So you know that the x value is 0 because it's the intercept, y-intercept. A is the y-intercept of this line. So you already know the x coordinate. To find the y coordinate, we simply substitute x equal to 0 in this equation here. So 2 times 0 is 0, and then y equals to 13 over 3, which is 4 whole 1 over 3. So your x coordinate is 0 and your y coordinate is 4 whole 1 by 3. Part B is the shaded region R is defined by 5 inequalities. 2 of these are x is less than equal to 6 and y is less than equal to 6. So x is less than equal to 6 is this line here. Since it's a horizontal line at x equals to, oh sorry, y equals to 6. So this line on the top, let me mark this in blue. So this line on the top, this represents the inequality y is less than equal to 6. And this one here on the right, and let me mark this in black here, this represents the inequality x is less than equal to 6. Write down the other 3 inequalities. So the other 3 inequalities that represent this region R will be the equations of line, this represented in green here. Let me choose a different color. Let me again go with, so let me go with gray here. So this line represented in gray here, and then this line represented in red here. So we have to find these 3 inequalities. So these, the green one and the red one is pretty simple because green is a horizontal line and it's at y equals to 2. So this, the equation of this line is y equals to 2, right? So y equals to 2. But since the region, shaded region is above this line, so your inequality will become y is greater than equal to 2. And similarly, this is a vertical line at x equals to 1. So the equation of this line is x equals to 1, but the region is towards the right side. So you again get x is greater than equal to 1. So this is your second inequality. And the third inequality will be represented by the equation of this line, which we are given here. And since the region is above this line, so this equation becomes 3y plus 2x, and again similarly greater than equal to 13. So these are the other 3 inequalities that represent this region R. Part C is the point P is in the shaded region R. Given that AP is as large as possible, write down the coordinates of P. So P lies somewhere in this region R, and A is the point here. So let me mark A here. So you have to find the coordinates of P such that the length AP would be largest. So if I start from here, this is a very small length compared to if I move my point P all the way towards the right here, right? So if P has to be on this boundary somewhere because this is as far as possible from A while remaining in region R. So it has to be somewhere on this line. Now the question is where on this line. If we draw this straight line here, this is a larger distance, but we can also move up and down. That will further increase the distance of P from A. So if I have P on this top corner or P at this bottom corner, I have to choose which one is further away. So if you look at the height of this, like length of this line, it's 4 units. 1, 2, 3, 4, 4 small boxes. And A is, so two, like this would be the midpoint of this line. Let's call this line not PQ. Let's call this line UV. So let's call this U, this point U, and this point V. So UV is this line, and this is the midpoint here, right? So the straight line coming from A is already above the midpoint. So if I have P at this edge, at this corner, it will be closer to A compared to this, because this distance is greater than this distance. So my P would be at this bottom right corner, and the coordinates of this point are, the x coordinate is 6 and the y coordinate is 2. So my coordinates of P would be 6, 2, which is the bottom right corner. So this is the greatest possible distance P can have. So that satisfies the condition that P is in the region R. So this bottom corner is within the region R, and AP is as large as possible. Your length of AP cannot be larger than this if you move P anywhere else in this region R. So question 26 is two sequences have 1, 3, 5 as their first three terms. In the first sequence, each term is 2 more than the term before it. So that means your first term is 1, and then your second term is 1 plus 2. So let's call this the first term, this is the second term, and your third term would be 1 plus 2, which was your previous term, and then you add another 2 to get your third term. So you see a pattern here where you add 2 to get the next term, and the number of times you add 2 is 1 less than the term number. So if you're looking for the third value, you will add 2 times to the first value. So that means, and here you can see, to find the second value, you will add 2 just once. So how many times are you adding 2? You're adding 2 n minus 1 times, and then into 2. So I can also, so this 2 is just basically here. So if you're looking for the first term, this would be 1 minus 1, 0, and 2 times 0 is 0. That is correct. In the first term, we do not add any 2. In the second term, you will replace n with 2. You will get 2 minus 1, 1, and 1 multiplied by 2 will be 2. So you will add 2 just once, and then so on. So if I can simplify this, so 2, if I open the brackets, 2n minus 2, minus 2 plus 1 is minus 1, so you get 2n minus 1 as your answer. The second part is the kth term of this sequence is 841. Find the value of k. So I just simply replace n with k. So to find the kth term, it will become 2k minus 1, and I'm given that this value is 841. So this becomes 841. 2k equals to 842, and then k becomes 421, so 421. And then for part B, you're given that the nth term of the second sequence is given by this. Find the fourth term of the sequence. So to find the fourth term, let's call it T4. I'll just simply replace n with 4, so I get 2 to the power 4 minus 1 minus, again, n, 4 minus 1, and n again is 4, so 4 minus 4 over 2. So this becomes 4 minus 1, 2 to the power 3. Since this 4 minus 4 is 0, so this whole term becomes 0. This is just 0. And then you know 2 power 3 is 8. So this is your answer, 8. Find the fifth term in the sequence. Now t5, I'll again just simply replace n with 5. So I get 2 power 5 minus 1 minus again 5 minus 1, 5 minus 4 by 2. I get 2 power 4 minus, so you'll get 5 minus 1, 4, and then 5 minus 4 is 1, so anything multiplied by 1 is just itself. So 4 into 1 divided by 2. So I get 2 ones are 2, 2 times 2 is 2, and 2 power 4 is 16. So you'll get 16 minus 2, which will equal to 14. So your fifth term of this sequence is 14. So the next question is, the diagram shows the speed time graph of a car which slows down from 30 to 12 meter per second in the 20 seconds and then continues at a speed of 12 meter per second. Find the retardation when t equals to 10. So you have to find the deceleration or the retardation. So t is equals to 10 will be somewhere in the middle of 0 and 20. So this would be, so this is the value you are basically looking for. So since this is a straight line, your deceleration is basically, or retardation is basically the gradient of the graph. So if you find the gradient anywhere between these 2 points, you will have the same value. So I can simply find the retardation by looking at these boundary values, since the retardation is same constant throughout, because it is a straight line, the gradient is constant. So retardation is change in value of y, so it will be 30 minus 12, and then change in x-axis is 20. So you will get a retardation, 30 minus 12 is 20, sorry, 18 over 20, which would be equal to 2 times 10, 2 times 9. So 9 over 10 is 0. Let me erase this. 9 by 10 would be 0.9 meter per second square. So your answer is 0.9. So this is your deceleration or retardation throughout from t0 till t20. And at t20, your retardation or acceleration becomes 0, since the line is horizontal after that. So you're just traveling, the car is just traveling at constant speed after that. Part B is find the distance traveled by the car between t is equals to 0 and t equals to 20. So distance is given by the area under the graph. So basically between 0 and 20, you have to find this whole area, right? So if you look at this shape, it is a trapezium with height 20, and the two parallel sides, one side is 30 and the other side here is 12. So distance would be 1 by 2 into height is 20, and then the sum of parallel sides is 30 plus 12. So 30 plus 12. So this would become 10. 30 plus 12 is 42. 42 times 10 is 420. So 420 meters is the distance that the car traveled between t is equals to 0 and 20. So the distance, part C is the distance traveled by the car between t equals to 20 and t equals to k is 60 meters. Find the value of k. So let me erase this so it's a little bit neater. So the distance between t equals to 20 and t equals to k is 60 meters. So the area, this area here, let me actually represent this in red. So all this area will give you the distance traveled by the car. This area in red will give you the distance traveled by the car between time 20 and k. So since this is a rectangle, your area would be given by, so distance equals to area under the graph. So your height is 12 and your width is k minus 20, right? So this is the value on the x-axis. So your area of this rectangle will be length into width, which is 12 into k minus 20. So distance you're given is 60, which is equals to 12 into k minus 20. I can take the 12 to the other side. This becomes 5 equals to k minus 20. And this gives me, if I take 20 to the other side, this gives me k equals to 25. So the value of k is 25. So that was the last question. So this was Mathematics Paper 1, Variant 2 for October-November 2016.